Hello everyone. In this video we're going to talk about how to make conclusions on hypothesis tests using confidence interval. Well, in general, once you form your confidence interval with a lower limit and upper limit, you would reject your null hypothesis if the hypothesized population mean in your test is not in the confidence interval. Well, let's look at different types of alternative hypotheses that we may have in any hypothesis test. You may have a two-sided alternative hypothesis, and in that case you construct the confidence interval on the mu and you make the decision using this rule. Or if you have a one-sided test, here in this case we have a one-sided alternative hypothesis with mu more than mu naught and here mu less than mu naught. It's very important to calculate the right confidence interval. If your test is a one-sided test with mu more than mu naught, then you would have to calculate the lower confidence interval. Basically, your confidence interval is going to look like, with a lower confidence limit, and the upper confidence limit is infinity. And if your alternative hypothesis has mu less than mu naught, then you need an upper confidence limit. Confidence interval is going to be negative infinity all the way to an upper confidence limit. And this is how you make a decision. You would reject your null hypothesis if mu naught is not in the confidence interval. So this mu naught is something that you would have to check against the confidence interval, and you make a decision. For a two-sided confidence interval, you would have a confidence interval with a lower limit and upper limit. If the mu naught is not in the confidence interval, you reject the null hypothesis. Otherwise, you fail to reject. A very important point here is that in hypothesis testing, we have these three methods of making decisions. We have critical region, we have p-value, we have confidence interval. It is very important here to remember that these three methods will result in the same decision. These are just different ways of making a conclusion about a hypothesis test. And all three of them will give you the same conclusion. It's just different ways of conducting the hypothesis test. So let's look at one example here that we had before. This is the example of volume of bottles. Basically, a company is making bottles and they want to make sure that the volume of these bottles is equal to 12.2 and alternative hypothesis mu more than 12.2. They don't want to produce bottles that have volumes of more than 12.2 ounces. So what we do is we collect a sample of 30 bottles and we take the average volume of them, that's 12.23. With the alpha of 1%, use a confidence interval to evaluate the hypothesis test. So here we have everything that we need about a hypothesis test. First, we know that our mu naught, and we also know that our test is a one-sided test. One-sided hypothesis test. And with those two, we're basically looking at a confidence interval of this type, because our hypothesis test is one-sided with more than sign. So we need to calculate the lower confidence limit. And how do we calculate lower confidence limit? If I go back a few slides, here is lower confidence limit. X bar minus z of alpha times sigma over square root of n. So I'll be calculating that L, or lower confidence limit, is x bar minus z of alpha sigma square root of n 12.23, that's our sample average, minus z of 0.01 times 0.08 ounces over square root of 30. And this z value is 2.32. You can read it from the normal z table. And when you do the math here, that is equal to 12.196. And that is the lower confidence limit. Basically, since our alpha is 0.01, the confidence interval that we have here is a 99% confidence interval that is starting at 12.196, goes to infinity. That's a one-sided confidence interval. It is 99% confidence interval because that is 1 minus alpha. And what does this mean, this confidence interval? What does that mean? This means that with 99% probability, the average volume of bottles is greater than 12.196. So let me write that down. Yes, this means that with 99% probability, the average volume of bottles is greater than 12.196. So now, how do we make a decision here about our hypothesis test? We were hypothesizing that the average volume of these bottles is 12.2, and the alternative hypothesis says more than 12.2. Now, we are saying with 99% probability, the average volume is more than 12.196. Well, the way that we make a decision is we compare all mu naught with the confidence interval. If it is within the confidence interval, we fail to reject the null hypothesis. And if it's outside the confidence interval, we reject the null hypothesis. In this case, 12.2 is within this confidence interval. So, mu naught is equal to 12.2, and that is within this confidence interval. Therefore, we fail to reject the null hypothesis. Basically, we fail to reject that the average volumes of these bottles is 12.2. We fail to reject that. We quote-unquote accept that.